Good morning to all. Today I will be discussing in the physical chemistry 2, that is block 1, theories of chemical kinetics. In that I will be discussing unit 4, is just affecting the order of reaction, primary and secondary, salt effects, effects of dielectric constant and pressure volume for the rate of reaction. So these are all the things which comes under the chemical kinetics. So with respect to reaction, we are going to calculate the primary and secondary salt effect, ionization, and also with respect to keeping dielectric pressure and volume of the reactant kept constant. By varying these pressure, volume, and dielectric constant, we are going to measure the rate constant. So chemical kinetics ಅಂದ್ರೆ ಏನು? It's mainly for measuring the rate constant or rate of the reaction with different attitudes. So here with respect to pressure, volume, also with respect to primary and secondary salt effects with different natures, we are going to study the rate of reactions. So in the unit for thermodynamics, it is little bit related to thermodynamics. Why thermodynamics is included in chemical kinetics? Andre, thermodynamics, it is mainly for the study of energy, energy transformation, and its relation to matters. So these are the certain things which related to chemical kinetics. So that's the relation between the thermodynamics and chemical kinetics. Chemical kinetics ಅಲ್ಲಿ we are going to measure mainly the reaction rate or rate of reaction. So why you are going to implement thermodynamics in this part ಅಂದ್ರೆ by varying concentration, by varying surface area, temperature, catalysis, and radiations. Also, thermodynamics is mainly for the study of energy, energy transformation, and its relation to matters. So, this is with respect to thermodynamics. So, thermodynamics has nothing to say about the rate of which the reaction can be transferred into product. But some of the reactions are instantaneous or it may take long time, as previously discussed. Some of the examples are rusting of iron, it take weeks together, or uranium to plutonium, where it takes 5 into 10 to the power of minus 9 years for the conversion of uranium to plutonium. So these are the, it depends on the reactants for the conversion of the reaction to product. So thermodynamics, which is not considerably in these matters, but also some of the factors affecting reaction rate. Some concentrations such as increases, factors affecting reaction rates such as concentrations. So some of the factors affecting the reaction rate such as concentration. The reaction rate, it may vary depending on the concentration of the reactant also. Also the surface area of that molecules. If the surface area of the molecules is large, mean it may take more time for the conversion of the product. So also with respect to temperature, as the temperature increases, some of the reaction may complete faster. So also with respect to catalysis. So while you are using some as the catalyst, so the reaction, what the use of catalysis? Catalyst ಏನ್ ಮಾಡುತ್ತೆ? Whether the reaction increases or decreases the rate of reaction, catalyst can be used. So also with respect to radiations, some of the UV radiation by penetrating to the reactions, well, can be increased the rate of reaction. So also some of our site slightly influences the rate constant and of the chemical reactions. These are the factors. And coming for the reaction taking place. And also in the second point, salting effect. Salt effect. What does the salt effect? Salt effect, the effect of ionic strength on the rate constant of a reaction is referred as salt effect. So rate constant andre rate of the reaction. So the effect of ionic strength means ionic strength. What does the ionic strength says here? And the reactant to strength of the ionic of each molecule. Ionic strength ಏನಿರುತ್ತೆ of the each reactant, it depends for the reaction. So it also depends for the completion or rate of the reaction. The effect of ionic strength of the rate of reaction is referred as salt effect. So salt effect is nothing but the strength of the ionic strength of the reactant, whether the increases or decreases the rate reaction. So whatever the reactants you have taken, ಅದರದ್ದು ionic strength depend ಆಗುತ್ತೆ. Rate of reaction will increase or decreases. So the charges on the reacting ions, these are the type salt in the scene. So depends on the charges on the reacting ions. So and also the ionic strength of the solution, whatever the solution taken for the reaction, other the ionic strength also it depends for the rate of the reaction. So there are two types of salting effects. So primary salt effect and secondary salt effect. So the primary salt is the in the influence of electrolyte concentration on the activity coefficient of the reactant in the active complex is called primary salt effect. The influence of electrolyte concentration means whatever the concentration of the reactant on the activity coefficient of the reactant and the activity complex, activated complex andre previously I have discussed in the previous. What does this mean? Activated complex andre it's nothing but the intermediate formed between the reactant and the product. ಈ ಇದು reactant, this will be the intermediate and this will be the product formed. So this will be also be known as activated complex. So it mainly depends on the rate of reaction in the primary salt effect andre this reaction mainly depends on the electrolyte used for the reaction. So these two uh, whatever the molecules were taken for the reaction, the whatever the electrolyte solution used in the activity coefficient, also it also depends on the activated complex, that is with respect to intermediate is called as primary salt effect. So it mainly depends on the electrolyte and also the activated complex for the rate of reaction. So for example, here we have taken A, Z, A. So what does the ZA represent? And here ZA and ZB is the right. ZA is the charges of the reactant. Whatever the ionic strength alva illi we are going to calculate ion number of ions present in the each molecules. So number of charges present in the each molecule ZA and ZB represent the charges of the reactant. So when it further it forms the intermediate that of AB of ZA plus ZB. So it represent the ZA and ZB represent the charges of the reactants. So for bimolecular rate constant, what you are going to take? Either unimolecular or bimolecular. In previously, I have discussed in the previous unit. So two molecules are present. It is bimolecular reaction. So here the rate constant how you are going to calculate andre log of k is equal to log of k naught plus log of tau a tau b by tau ash. Tau ash is nothing but the intermediate formed. So tau A and tau B are nothing but this. Tau A and tau B are nothing but tau A and tau B are nothing but another. It is the elementary substance particle similar to electrons. So number of electrons present in the each reactants and the product form that you are going to take it here for the calculation of bimolecular rate constant. So K represent the bimolecular rate constant. So in the equation 2 we are going to insert the Brownstone-Milgram equation. So this equation says this equation is nothing but the effect of salt added or rate constant of the ionic strength that you are going to calculate from this equation. So rate constant in the ionic strength andre it can be written as since K and K naught are the rate constant since K and K naught are rate constant. K naught is the rate constant at infinite dilution. So dilution andre whatever the electrolyte you have taken for the reactant to dilute. So tau A, tau B and tau ash are activity coefficient of reactant A, B and active product. So since it can be written as log tau A by tau A tau B by tau ash. So that can be 1.02 of ZA ZB of root mu. So ZA and ZB are nothing but another charges of reactant. So this reactant the charges. Then you can calculate log of K is equal to log K naught plus 1.02 ZA ZB of root mu. That is the equation 3, which mainly the rate constant depends on the ionic strength of the medium. So rate constant mainly depends on the ionic strength of the medium andre whatever the medium. That is what the primary salt effect says here. It mainly depends on the concentration of the activity of electrolyte and the complex. So the concentration, the primary salt effect. Mu changes as the K changes. This is called primary salt effect. As the rate of reaction changes, the primary salting effect also, ionic strength of the solution also changes. So this mu is nothing but root mu anta ideyala. So mu is nothing but the ionic strength of the solution. Ionic strength, whatever the reactants we are taken in the solution. So that ionic strength of the solution varies. Also, the rate of reaction also changes. So this is with respect to primary salt effect. And here three different cases are given. So varying the concentration means different ionic strength or different charges present in the reactant. ಈಗ ಎ ಬಿ ಇದು ಡಿಫ್ರೆಂಟ್ ಚಾರ್ಜಸ್ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೆ, ಒಂದು ಪ್ಲಸ್ ಒಂದು ಮೈನಸ್ ಇರುತ್ತೆ. ಸೊ ಹಿಯರ್ ವಿ ಆರ್ ಟೇಕನ್ three different examples. In the first example There are Za and Zb are of same type. Both are in positive ions or negative ions. So what are the examples for positive or negative ions ಗೆ ಏನ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಿದ್ದಾರೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಬೋತ್ ನೆಗೆಟಿವ್ ಅಯಾನ್ಸ್ ಇರೋದು ಯಾವ್ದು ತಗೊಂಡಿದ್ದಾರೆ peroxy disulfide plus 2 iodine. So that forms iodine plus 2 sulfate. So that is the reaction they are taken. So the two reactants are in the negative, they are having negative charges. So that is the primary salt effect. Two examples are two reactants are in the negative andaga. What does the plot says? Plot ಏನು ಹೇಳುತ್ತೆ? So this is log K is nothing but the rate constant or rate of reaction. Mu is nothing but the ionic strength of the solution. Both positive idaga or both negative idaga, as the rate of reaction increases, even the ionic strength of the solution also increases. As the see, as the rate of reaction increases, the ionic strength of the solution also increases. So this is the plot. It goes simultaneously increases as the rate of reaction increases. Erdo positive are both are negative ions present in that. So this is the first example. And in the second example, we are going to discuss keeping one positive, one negative, or negative positive. So here we are taken the example of hydrogen peroxide plus bromine gives 2 moles of hydrogen, which gives water plus bromine. So as the rate of reaction increases, the ionic strength of the solution decreases. So you can see the ionic strength of the solution is decreased while having two different ions. One is positive and negative in the molecule. So hydrogen peroxide, which is in the positive, where bromine, which is in the negative. So gives the plot. The ionic strength of the solution decreases. In the third example, we are going to take sucrose, that is C12H22O11, that is sucrose in the presence of water gives 2 moles of glucose. 2 moles of glucose has been formed. So here there will be no positive or negative. It is both the reactants are in neutral. So Z and ZB will be 0. So it will be in constant. So K rate constant will not be affected by salting effect, means by ionic effect. So it will be in the constant. The rate of reaction will not increases as the ionic strength of the solution is increased. It will be rate of reaction will be in the constant. So this is with respect to sucrose, where forms 2 moles of glucose. And this is the combined plot of three different cases, that is case 1, case 2 and case 3. Three different cases what we have taken previous example, that is plotted in single graph. And coming to the next is secondary salt effect. We have seen primary salt effect. It mainly depends on the primary salt effect. It mainly depends on the electrolyte concentration and also activated complex. So concentration of the electrolyte, it mainly depends. So in the secondary salt effect, it is mainly depends on the charge, means the secondary it is related to charge introduced by the salt in the ionization constant of a weak acid. So number of charge in the weak acid, the secondary salt effect can be seen. So KAH, that is the dissociation concentrate of acid, HA, or it can be represented as acid dissociation constant. So the change in rate due to actual change in concentration of the catalyzing ions. So the change in rate due to the change in rate varies due to concentration of ions, resulting the formation of addition of electrolyte is called secondary salt effect. So example here we have taken weak acid. So weak acid which dissociates to give HA. HA represent acid which dissociates to give in the presence of water. Water add ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? It dissociates to give hydronium plus ion. So here S3O plus, that is hydronium ion we have taken, which can be written, rate constant can be calculated. ಇದಕ್ಕೆಲ್ಲ for the product we are going to calculate the rate constant. So whatever the product form, at what rate the reaction is taken place anta product form ಆಗಿರೋದಕ್ಕೆ. So then Ka is equal to this equation, that is equation 1, dissociate constant. Also further, Ka can be denoted as dissociation constant, and CH3O, catalysis of hydronium ion. HA is the weak acid. So this further equation be derived the concentration of catalysis. So here what does the de-Becquerel theory says? Under de-Becquerel theory, it is the electrolyte completely dissociates into ion into solution. So how ions acts in the solution? It can be known by de-Becquerel theory. So the charge, whatever the change in the change of catalysis concentration indirectly influences the rate of reaction. So whatever the changes taken place in the catalysis concentration indirectly influences the rate of reaction. So here also we have taken few examples to understand that theory. Here we have taken ammonium plus water gives hydronium plus ammonia. So we are going to calculate the rate constant for the reaction is denoted as catalysis of hydronium ion. Mu is the ionic strength of the solution, and H3O, that is the positive charge in the aqueous cation. So the value of mu can be denoted calculated under the ionic strength of the solution can be calculated. For example, the catalyzing of ions in the ferric hydroxide, which gives one more example they have taken here. Go through this. So next topic is effect of dielectric constant of the medium of the rate of reaction. So here two electric charges placed at definite distance in the distance that is of r apart from uniform medium. So E1 and E2 are the value of electric charges of the molecules and placed at distance r apart from the uniform media. So how we are going to calculate dielectric constant of the medium of the rate of reaction andre. So it can be calculated using F is equal to E1 E2 by D R square. So that is the Coulomb's law. So what does the Coulomb's law states andre? It the magnitude of the electrostatic force of attraction or repulsion between 2 point charges is directly to the product of magnitude charges. So whatever the magnitude electrostatic force of attraction or repulsion between 2 point charges directly to the product of magnitude charges. So D value of some liquid 25 degree is follows. For example, they are taken dielectric of 25 degree for Xn is 1.9 and carbon tetrachloride that will be of dielectric charge ido. Xn the 1.9 carbon tetrachloride that is of 2.24 ethanol is 24.3. So these are the dielectric charges and non-polar substance the carbon tetrachloride and benzene are very low in D value. So this is with respect to dielectric charges. And double sphere model and single sphere model andre it's nothing but next topic is double sphere model. So double sphere model two reactants were taken forming the intermediate and further forming the product. So two reactants that are ZA and ZB. So double sphere model it won't get in contact with each other, means ions will not get contact with each other. So next single sphere model anta ideyala, so in this it will get contact and become single sphere. So that is the difference between double sphere model and single sphere model. These two are the reactants what we are taken. Some of them will merge and some of them will be in the two different stage. So that is the difference between double sphere and single sphere model. So here the value of K increases or decreases depending on the reaction between positive and negative ions. So same plots what I explained in the previously, as the rate of reaction increase, the ionic strength will get decreases when it is having positive minus negative different ions. When rate of reaction also increases, the ionic strength of the electrolyte or solution increases, means both are positive or both are in negative ions. When it is constant andre, the the rate of reaction is constant, as increase in the ionic strength andre both the ions will be in the neutral zero. A and B ಎರಡು ರಿಯಾಕ್ಟೆಂಟ್ ಹೊಂದಿರ್ತೀವಲ್ಲ ಎರಡರದ್ದು ion state will be in the neutral. So this is with respect to three different plots. So that is with the double sphere model and single sphere model, where ions get in contact with each other. In double sphere model will be in contact ಅಷ್ಟೇ. In single sphere model it becomes either one. So the activated complex formed as single sphere with net charges is equal to algebraic sum of the charges on the individual ions. So that is with respect to single sphere model. So effect next is effect of pressure volume on the rate of reaction. So that's why in the beginning of the class I discussed with the thermodynamics. Thermodynamics andre it is the study of energy transformation and its relation to matter. So whatever the energy comes in or goes out of the system, that can be calculated So that why you are going to insert in the chemical kinetics andre by varying the pressure and volume we can study the rate of the reaction. So rate of reaction is mainly depend, it's of chemical kinetics ala. So with varying pressure volume, also in the further with different ion charges, and we are going to calculate the derive the equation for rate of reaction with effect of pressure and volume. So the rate of reaction in the solution is nearly independent of the pressure. If it is in the solution, it will be of independent of the pressure. It won't be depending on the pressure. So as the pressure varies, it won't the rate of reaction will not vary. So at high pressure, measurable changes in the reaction rate have been observed. With high pressure, some of the varies the reaction rate of the reaction. So delta G is equal to minus RT, where delta G is the standard free energy, K is the equilibrium constant, R is the gas constant, T is with respect to temperature. So that further we are going to respect to in temperature we are going to cat, right? And here delta V as represent the molar volume changes. So whatever the volume changes in the product that can be calculated by using free energy by pressure. So further you go through this mathematical term as pressure is applied, the pressure will be of 0 or K of K naught, rate constant that can be denoted as K naught when the pressure is in 0. This is with respect to effect of pressure on volume of the rate of reaction. So three cases are there: normal rate. In this case, delta V ash is negligible and small, and also almost independent of the applied pressure. So one more, they have taken 2 plus 2 intermediate that of 2 plus hydroxide ion with primary halides, that is SN2 reaction. So from this plot, what does it says andre ln of K or log of K andre as the rate of reaction increases, this is the applied pressure. P represent the applied pressure. So as the pressure is increased, there will be small variation in the rate of reaction. ಇಲ್ಲಿ increase ಆಗಿದೆ ಅಲ್ಲ, ಸ್ವಲ್ಪ pressure increase ಮಾಡ್ತಾ ಹೋದ್ರೆ the reaction the rate of reaction also has been increased. You can see that is from the plot we have got. That is delta V, volume of activation. So next slow reaction though, what it says andre the rate of as the pressure is increased, the rate of reaction also increased, where delta V volume of activation. This is with respect to slow reaction. When the reaction is in fast state, there will be in normal. Means fast reaction only, the pressure will not be varied much. Pressure ಅಷ್ಟು ಡಿಸ್ಟರ್ಬ್ ಮಾಡಲ್ಲ ರಿಯಾಕ್ಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗೋದನ್ನ ಫಾಸ್ಟ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಲ್ಲಿ. ಸೊ ದಟ್ ಈಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಫಾಸ್ಟ್ ರಿಯಾಕ್ಷನ್. ಸೊ here they take an example for fast reaction ಗೆ pentamine sulfur cobalt 3 bromide. So next topic is significance of delta V. So ash. So delta V is nothing but the volume of activation. So volume of activation andre EA andre energy of activation. Delta V andre volume of activation. As the volume increases with respect to rate of reaction. So you can see three different plots. The previous case and more case idella. So that we can see three different. When it is in the both are in negative, the rate of reaction increases. Both are in neutral. The ion it will be in stable. So when it is in positive, the rate of reaction decreases. So delta is the entropy of activation. Delta V is the volume of activation. So here studying of kinetic of reaction at different pressure gives information about the value of delta S ash and delta V ash. Whether the reaction is fast, slow, and the nature of activated complex formed. So depending on the kinetics of reaction. So it differs by varying the pressure and volume. You can determine whether the reaction is fast, slow, or the nature of the activated complex can be studied. So this is the end of the unit. So this summary of the unit, whole summary, it on summary. If you go through this whole unit, you will get an idea what's the